Remember that radicals and exponentials are inverse operations. So for example, if you raise a radicand of x to the power of y, but then also y is the index of the root or the radical, you end up with just x. The y's cancel out. So for example, you can say if you raise 2 squared, 2 to the power of 2, and then you take the square root of that, you're going to end up with 2. If you raise x to the cubed power, x to the third power, and you take the cube root of that, you're going to end up with x. Another way to look at that is you're saying over here, x times x times x, which is x cubed, and you take the cube root of that, you end up with just x, because those are inverse operations. So what this means when we are trying to simplify a radical, if, for example, with our square root of 16, remember the understood index is 2 over here. When I write 16 out in my prime factorization, if I see numbers that are being squared, since that's the index, that's like having the inverse operation being done within my radicand. So I can actually pull some of these out and turn them into constants. What that means is this is the same as saying 2 times 2 or 2 squared, and then you take the square root of that. That's the same as 2. And then you have another 2 times 2, which is 2 squared. That just equals 2 when you take the square root of it. So the square root of 16, as you can see then, equals 4. Let's look at a couple more examples. Square root of 80, we prime factor out 80. Since I'm taking the square root of, here I have 2 to the second power and another set of 2 to the second power, right? 2 squared and square root of that is just equal to 2. So this is the same as saying 2 squared times 2 squared times 5. And if you take the root of 2 squared, you end up with 2. That's times 2 again, times the square root of 5. So square root of 80 is the same as 4 root 5. One more example. This time we have a radicand of 3. So we're looking for any prime factors in here that are actually raised to the third power. And in fact, 2 is cubed in here, so we could also rewrite this prime factorization as 2 cubed times 3 times 13. Don't forget that index over there. And 2 cubed, remember, 2 cubed to the third root is just equal to 2. So I can pull that 2 out as a constant, and then you're still multiplying it by the root of 3 times 13. That's the same as 2 root 39. I'm sorry, don't forget those indexes over there, because 2 to the cube root is not the same as 2 to the root. So simplified version of cube root of 312 is 2 times the cube root of 39.